Hexadecimal is a numerical notation popular with computer programmers for a very particular reason. Computers basically use binary for their internal processing of data and math, and binary numbers can be very difficult for humans to work with, very tedious. It turns out hexadecimal maps very well onto the layout of binary data with greater information density. Normally, when we represent numbers, we use a system of 10 unique digit symbols to write them out. However, we can choose to use different sets of any size we like. In a previous video, I tried to explain how we can do this with only 2 symbols. Binary is very good for accurately conveying how computers internally handle numbers, but it is very difficult for humans to work with. Yet also, computer programmers may often find themselves needing to work with a type of notation which accurately handles the idiosyncrasies of binary without being quite as tedious. This is a role well filled by hexadecimal. Also called base 16, 16 is equal to 2 to the power of 4, granting base 16 a special quality in relation to binary numbers. Every single hexadecimal digit cleanly represents 4 binary digits. So well, in fact, that you don't need to do any math to translate between hexadecimal and binary. Only remember which sequence of 4 binary digits corresponds to which hexadecimal digits. When it comes to doing math by hand, hexadecimal is easier. Hexadecimal numbers are written with all the usual digit symbols from decimal, plus extra symbols, usually A, B, C, D, E, and F. This is not the only hexadecimal notation, but it is by far the most common. Counting up from 0 starts as usual, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, but instead of carrying over to make 10, we continue counting. What would normally be equal to 10 is A, 11B, 12C, 13D, 14E, 15F. And now that we finally run out of digit symbols to use, we carry over to write 10. In typical decimal numbers, consider that every time we move to a more significant digit to the left, that position's digit value represents for the number as a whole a value 10 times greater than what it would be for a lesser significant digit. Similar is true of hexadecimal. Every time we add a digit to the left, that digit is valued 16 times more than what came before on its right. Adding hexadecimal numbers means starting with the least significant digits and adding them together. Remembering the values of the letters, any result 9 or less can simply be written down as normal. If the result is 10, we replace it with an A, 11B, and so on. If the result is 16 or greater, we subtract 16 and carry a 1. And you can repeat this process for every more significant digit. If there's anything I can do to make videos like this clearer and better, by all means let me know in the comments. If you want to see more videos like this, consider subscribing. In any case, go make your day a good day. You deserve it.